So for this problem, we want to write this expression as both a product and a sum. So for the product, I look at the length and the width. Length being 4x plus 5, which is down here, because I have 4x tiles, and I have 5 individual tiles. And then the width is 2x plus 3, because I have 2x tiles and 3 individual tiles. So if I want to write this as a product, for example, length times width, I would write 4x plus 5 times 2x plus 3. And that is a product. To write it as a sum, I would look at each individual tile and add them all up together. Since I have like terms sort of clumped together, I can see here that I have 8 tiles that are x squared. So I have 8x squared. If I count all of the x tiles, I have 12 and 10, which makes 22 x tiles. And then if I look at the singles, I have 15. So writing it as a sum, I look at the like terms and I combine them together. So my x's, even though I have some here and some here, I can combine those together, and then my individuals. And when we're ready to move on from the algebra tiles, instead of having to build the whole expression with tiles, I can simply write 4x on the outside of a generic rectangle. And if I want to multiply 2x times 4x, I would write 2x as the width, 4x as the length. When I multiply those together, I get 8x squared. If I want to multiply a binomial, meaning I have more than one term in the expression, then I would just add that to the generic rectangle. For example, this expression here is 4x plus 5. So I have my 4x as one type of tile and my 5 as another type of tile. Same thing up here, I have 2x plus 3, but I separate them in terms of what type of tile they would be. But instead of having to lay all of the tiles out, now I can just write the term in and then multiply those two terms. So 2x times 4x is 8x squared. 3 times 4x is 12x, and so on, so that I get the sum of 8x squared. I can combine the 12x and the 10x to be 22x, and then I add the 15. So that's using the generic rectangle instead of the algebra tiles.